Look at question 5 from the 2014 Revised Higher Physics paper. It says the graph shows how the energy emitted per second from the hot surface of a hot object, from the surface of a hot object varies with wavelength lambda of the emitted radiation at different temperatures. Now this is a graph you should be familiar with when studying stars and just looking how the peak wavelength changes with temperature, showing that the color of the stars changes effectively with temperature. So we'll have a look at the statements that the student makes, and the question obviously is which of these statements are true. A very common style of question. So we'll go through each statement in turn and we'll try and look at the graph and see what we can determine about it. First statement: as the temperature of the object increases, the total energy emitted decreases. Well, what's happening to the temperature of the objects? This one is a very hot star and its total energy is very large. This one's a cool star, its total energy is very small. So as the temperature of the object increases, the total energy decreases. I would say that's incorrect. As the temperature increases, then the energy emitted also increases. So that one's wrong. The second one, it says as the temperature of the object increases, the peak wavelength of the emitted radiation decreases. So let's have another look at that. As the temperature of the object increases, so again this is a hot one, its peak wavelength, you can't see it, it's just off the screen, but it's about there. And the next one has a peak wavelength of 5000, which is about there, the 4000, which is here. So the peak wavelength is getting lower and lower, or shorter, as the temperature gets hotter. And so is that what that says? Yes, it is. As the peak wavelength, as the temperature increases, the peak wavelength decreases. So this one is correct. So then the final one says the frequency of the emitted radiation steadily increases. Now we don't have a graph showing frequency, we have one showing wavelength, so let's just convert that into wavelength. V equals f lambda, so lambda is equal to V over f. And in other words, our wavelength is proportional, inversely proportional to the frequency. So the frequency of the emitted radiation increases. That means as the wavelength decreases, so as this wavelength goes down, it says that the energy emitted decreases as well. So that would imply some kind of graph like this, straight line graph. As that drops, this drops as well. And that's clearly not what's happening in this graph. It's much more complicated than that. So this one is not correct. So the only ones that are correct are just two. 1 and 3 are incorrect. So if we look at the options, we can see the only one that says 2 is B. So that's the one that we'll circle right now. There we go.